Okay. Now we start off with trigonometric ratios. Now this is lecture number 2 of trigonometry. Now considering that trigonometric ratios will be used, now there are 3 types of trigonometric ratios that we'll be dealing on. One is the sine ratio, the other one is the cosine ratio, and the third one is the tangent ratio. Now, these ratios are basically linked with 3 formula that are sine theta, which is opposite upon hypotenuse. The other formula will be cos theta, which is adjacent upon hypotenuse. And the third formula is tan theta, which is opposite upon adjacent. Now, trigonometric ratios are basically applied on right angle triangle only. That means this cannot be applied if you have a non-right angle triangle. This will only be applied when you have right angle triangle. What is a right angle triangle? A right angle triangle has a 90-degree and two angles are basically acute angle. Two angles are basically acute angle. But one thing is very clear, that this 90-degree, the opposite to 90-degree is hypotenuse. But now you need to understand that these angles are very important. The acute angles are very important when we talk about the trigonometric ratio. That means if we consider this as theta, the remaining, a triangle sum of all the angle is equal to 180. Now, if 190-degree is gone, that means the remaining two angles will be 90-degree plus, obviously, let's say this is A, B, and C. So angle A plus angle C. So considering that if 90-degree is there, the remaining angle A plus angle C will be 90-degree as well. So in this case, you should know that if A is theta, then angle C, if A is theta, let's just write down in this way, is if angle A is equal to theta, then angle C will be 90 minus theta. Then angle C will be 90 minus theta, which means that, let's just draw the right angle triangle again. This becomes your right angle triangle. This becomes A, B, and C. This is your 90-degree. So as I said, if this is theta, the other will become your 90 minus theta. So if this is 90 minus theta, you need to understand that the angle opposite to theta, opposite to 90 degrees hypotenuse. But we specially, when we talk about theta only, then opposite to theta is opposite, whereas this side will become your adjacent. Whereas on the other hand, if we have right angle triangle, this is 90-degree. Let's just make everything same, considering that this was theta and this side was 90 minus theta. So for the other side, for 90 minus theta, this side is basically opposite. And opposite to 90-degree is hypotenuse. So the remaining side will become adjacent. So the angle will decide which side is opposite. Opposite to 90-degree is what? Hypotenuse, right? Opposite to 90 degree is hypotenuse, but considering the fact that opposite to the angle will be opposite. Opposite to angle will be opposite always. The most important thing in this is that angle will decide the opposite side. Now, considering that, what will these ratios find us? The ratios, that means trigonometric ratios, will find us angle. Will find us angle. For angle, two sides will be given. For angles, two sides will be given. Whereas for side, one angle and one side will be given. That means if the examiner is asking anything about the trigonometric ratios, for angle, two sides will be given, and for side, one angle and one side will be given. Let's just take an example of such question. Let's just say, if this is right angle triangle, considering that this is angle A, angle B, and angle C. So every time, remember this, whenever we have angle, the side opposite to angle is for that particular angle. The side opposite to angle is that for that particular angle. So we can always consider that this side is A, this is B, and this becomes C. But all these small alphabets, right? All these small alphabets. Now, for if I want to find out for this theta, and I use sine theta, your sine theta is opposite upon hypotenuse. Your sine theta is opposite upon hypotenuse, which means sine theta will be A upon B. Sine theta will be A upon B. Opposite is the line CB, which is A, where hypotenuse is always opposite to 90 degree, which will be B. Similarly, cos theta is adjacent upon hypotenuse. So, cos theta here will be C upon B. This should be C upon B, because angle side opposite to the angle is opposite. So the remaining side becomes the adjacent, which is AB. So C upon B will define what? Cos theta here. So the last remaining thing here is that tan theta, and tan theta is opposite upon adjacent. That means it does not have hypotenuse. So that means tan theta will have A upon C. That means opposite to theta is A and adjacent to theta is C. Now, with the same diagram, if you look into it, as I said, that if we just create a right angle triangle again, considering that this is side A, side B, side C, that creates 90 degree as well. And we know that this angle, if this was theta, if this side was theta, let's just, if this was theta, so I know that this angle is 90 minus theta. So if I just say that here we need to find out angles for 90 minus theta. So your sine theta is always opposite upon hypotenuse. So in the place of theta now you have sine 90 minus theta. And 90 minus theta means, let's just write down that this will be small c, this will be small b, and this should be small a. So for this, you need to consider that sine your 90 minus theta will be opposite and hypotenuse, which is c upon b. That means this angle has just replaced these sides here. The formula is same. But in the previous example, when we took theta, the opposite was A. But now the opposite for 90 minus theta is C. Similarly, if we just do cos theta is equal to adjacent upon hypotenuse. So your cos 90 minus theta will be A upon B, because adjacent is A and B is hypotenuse, which is always opposite to 90°, which means clearly that if we want to have tan theta is opposite upon adjacent. So tan theta will be 90 minus theta will be C upon A. So this will be C upon A. So the trigonometric ratios or the side will involve the angle in it. For angle, the opposite side will always change, but the opposite to 90° will always remain hypotenuse. It's just the opposite side that will change due to the angle. Now, moving on to with an example question. Let's just say that we have been given a right angle triangle, considering this as A, B, and C. Do not assume this as right angle triangle unless this mark is not given. That means you have been given the sign or the example tells the horizontal meets the vertical. Now, in this question, we have been given, let's say, 3, and this is 5. One side is 3, the other side is 5. So, now I know one thing, that the side B, that means the 5 is basically hypotenuse. But 3 depends upon what angle we need to find, because two sides are given here. So if we find out angle A, for angle A, 3 becomes opposite. For angle A, 3 becomes opposite. Whereas for angle C, your 3 becomes adjacent. Whereas 5 in both cases is hypotenuse. 5 in both cases will become hypotenuse. So, considering, let's say, we need to find out angle A. So, opposite is given. For this angle, opposite is given, and the other side given is hypotenuse. So, sine theta involves opposite upon hypotenuse. What does it involve? Sine theta involves opposite upon hypotenuse. So if we need to find out angle A, so we'll write down this thing as sine theta is equal to opposite upon hypotenuse, which means sine A will be 3 upon 5. So the answer for A will be, because since we need to find out sine, we will use calculator here, and in calculator we will use shift sign, which will give me sine inverse. Whenever I need to find out A, I will be using shift sign, and then shift sign. This sign will move on the other side and become what? Sine inverse. And then we will multiply sine inverse by 3 upon 5. The answer for sine inverse 3 upon 5 is 36.86, which will be corrected to 36.9. So the answer here is 36.9 for angle A. Similarly, if we want to find out angle C with the same information that is given, with the same information, if we want to find out angle C, so that means now we will be making sure that we have to find out this angle. Now, opposite to 90-degree is hypotenuse, but opposite to this angle is opposite, which is not given. So the remaining side is adjacent. So adjacent is given and hypotenuse is given. So we'll be writing cos theta, which is adjacent upon hypotenuse. So which means if we just look at the question would be cos theta is equal to adjacent upon hypotenuse, which will involve cos C is equal to 3 upon 5, which means C will become cos inverse 3 upon 5, and the value of C will be 53.1. The value of C will be 53.1. Now, if we just look at the situation here, we just got to know that this is 36.9. We'll just draw the right angle triangle right here to understand the brief concept. Let's say this is your right angle triangle. Now, this angle was A, B, C. So this was 36.9 and this becomes 53.1. So if we see that the sum of triangle is 180-degree. So sum of triangle 180-degree, which means 90 plus 53.1 plus 36.9 is giving me 180-degree, which means whatever working that we have done is fully satisfying the equation of the sum of triangle here. Now, since we found out the angles here, now we could also be asked to find out sides. So, but for sides, let's say this is your right angle triangle. You have been given 53.1. You have been given 53.1 and the hypotenuse is given. Let's say this is A, B, and C. You have been told to find out CB. Now, when you know that your angle is given, this CB is basically opposite to the angle and opposite to 90 is given, which is hypotenuse. So we need to find out opposite and hypotenuse is given. So that means sine theta is involved here. So if sine theta is involved, the formula of sine theta is equal to opposite upon hypotenuse. So your theta is basically 53.1. Your opposite is CB, where hypotenuse is 5. So CB will be 5 sine 53.1. When we multiply sine 53.1 with 5, we have to solve sine 53.1 in the calculator and then multiply with 5. Your value for CB will be 4. That means the CB will become 4. Whereas, if we are told to find out AB, considering that your AB is adjacent now, because opposite is, we don't need opposite, we need adjacent. So adjacent is to be found out and hypotenuse is given. So we can always write down what? Cos theta. So cos theta is equal to adjacent upon hypotenuse, whereas cos 53.1 adjacent is AB and this is 5. So AB will be 5 cos 53.1. The only difference is sine and cos. So AB will be 3. So AB will be 3 and CB is 4. So here we can always find out the ways of finding the side using the angle and the given side. When will 10 be used? When the opposite or the adjacent is given. When the opposite or the adjacent is given and hypotenuse is not given, then 10 can be used particularly. Now, moving on to how this right angle triangle will involve the other triangles as well. Now, let's say that we have been given a triangle. And this is your triangle. And considering this triangle as an isosceles triangle, considering this triangle as isosceles triangle, if this angle is A, which means that isosceles triangle will involve, that means both the sides are same. So considering this will involve the line which can be moved from the point till the another line, creating a 90-degree. So that means two equal right angle triangles can be created in this. Two equal right angle triangles can be created in this. So that means if this particular is, let's say, 16. So we can say this side is 8 and the other side is also 8. This side is 8 and other side is also 8. This A will be divided equally, considering this is half A and this as half A. So again, when you have angle, this is your angle, and if the side is given, then you can always find out any side. Or when 90-degree is given and we got this side, we can always find out this angle as well. So isosceles property is generally used in the trigonometric isosceles property, or I would say isosceles triangle is also used in the, or used for the trigonometric ratio part. Now this isosceles can also be created in this form. We have a circle and we got center of circle creating two radiuses, and those two radiuses are meeting a chord. Now when we have two radius, that means these two radiuses are equal and that there is a chord. Now this will involve, that means a line that is extended from the center of the circle to the chord. This will also create a right angle triangle. This will also create a right angle triangle. That means this is the same property that we have just done, isosceles triangle property, which means this particular angle A will be now divided into two equal parts, which will be half A and half A. So, and if the length or any height is given, we can use trigonometric ratios for this particular question as well. So that means trigonometric ratios can be applied for isosceles triangle because it will create a 90-degree when we divide the isosceles triangle to two equal triangles, which means the property suggests that isosceles triangle is divided into two equal triangles. So the isosceles triangle can be divided into two equal triangles, and with respect to this, your trigonometric ratios as in sine theta, cos theta, and tan theta can be applied, because these trigonometric ratios can only be applied when we have right angle triangle. Considering that if we need to have this angle, this will be opposite, this will be hypotenuse, and this will be adjacent. Same for this angle, this is opposite, this is hypotenuse, and this is adjacent.